This isn't generally the kind of video I tend to create. I usually stick to tutorials. However, it's come to my attention recently that there are a significant amount of people that genuinely believe the earth is flat. Something I find quite curious and also quite shocking, actually, because I figured it was pretty obvious that the earth was round. However, in response to those people that believe it's a thing, I have done this video, and basically I'm going to go through three reasons slash experiments that I believe are straightforward, and also the experiments you can do yourself and you can see the results for yourself, and they disprove the flat earth theory. Experiment number one: go to the beach. Pick a nice sunny day, pack a picnic, and I want you to sit and wait and watch the horizon. Wait for something to emerge from the horizon. Now, as you're at the beach, I'm going to presume this is probably going to be a ship of some description. If you watch really carefully, you will notice that the ship looks like it is actually emerging from the sea as it comes over the horizon. This is because it's traveling around the curvature of the Earth, and from our viewpoint, so if I'm standing over here, all I see is the ship coming up, as if it's coming up from the sea, which obviously doesn't happen. It's not Pirates of the Caribbean. So if the Earth was flat, we wouldn't get this phenomena. What would happen is the ship would just slowly materialize from the distance. And we would only start seeing that based on A, how clear the day is, and B, how good our eyesight is. But we wouldn't get the phenomena where it looks like it's actually emerging from anything. It'll just appear when we can see it. So that is experiment number one. Experiment number two: you need a friend for this experiment, and your friend needs to be living someplace else in the world. You and your friend also need a large stick each. You're going to have stick A, and your friend's going to have stick B. You also need to have mobile phone access, because once you plant this stick into the ground, that stick will cast a shadow. And your friend with stick B, well, that stick's also going to produce a shadow. Now, I want you to wait until the sun gets directly above this stick. And at that point, we're not going to have a shadow that's going to be produced by stick A. And it is at this point that I want you to call your friend and ask, is stick B producing a shadow? Well, your friend will say, yes, stick B is producing a shadow. So this only happens because of the curvature of the Earth. This wouldn't happen on a flat Earth. On a flat Earth, stick A and stick B would produce exactly the same shadows at the same time. And obviously we know this just doesn't happen. Moving on to my third and final reason, our old friend, gravity. We experience the force of gravity every single day. You throw an apple up in the air and it'll go straight back towards the ground. Well, that's because we know anything with mass has gravity, and the Earth's a pretty big mass. So we are attracted towards the center of the Earth. So if I go ahead and presume that the Earth is round, here is my center, which means no matter where I stand on the Earth, whether it's here, here, or here, I'm going to experience that same force of attraction towards the center of the Earth. It's what keeps us on the ground. And I'm also going to just say that the Earth is a perfect sphere here. I know it's not, and there will be slight deviations in measurements, but for argument's sake, we can say that pretty much anywhere we stand is exactly the same force of gravity, no matter where we are on the surface of the Earth. Now, taking the flat Earth model, this is my flat Earth, and I'm just gonna, these are the centers of the flat Earth. This is a side view here. So if I was standing here, I would experience gravity in this direction, straight down. That's supposed to be down towards the center of mass. So if I chucked an apple up in the air here, it would go straight back down. However, if I was standing on the edge of the Earth, then the direction that I would be feeling this gravity is different. It's a horizontal pull towards the center of mass, towards the center of the flat Earth. And trees would be growing in diagonal directions because they grow opposite to the direction of gravity. And water would pool around the center of the flat Earth where the gravitational pull was strongest. And obviously, we know that this doesn't happen. So, those are my 3 reasons as to why flat Earth is just not a thing. Obviously, I could have picked many other reasons and little experiments for you to try to see the effects of a round Earth, spherical Earth. However, this video would go on for much, much longer, and I thought I would keep it fairly short and bearable, basically. But as always, if you've got any questions, please do message me, and I will get back to you as soon as I can. And thank you guys for watching.